Hi, welcome back to ChemTube channel. I'm Jaku Wong. Today we are going to look at Terengganu trial paper in paper 1. Okay, let's start. Question 1. Which of the following substance is made of iron? Okay, so A, zinc. Zinc is not the answer because zinc is the atom. Ammonium chloride. So ammonium chloride, yes, it is ions, because it consists of ammonium ions and then the chloride ions. So the answer is B lah. Okay. Then naphthalene. Naphthalene is a molecule, so it is not ions. Oxygen also molecule. So the answer is B. Next, question number 2. What is the meaning of Avogadro constant? It is the number of particles in 1 mole of substance. Okay, correct. Pressure of 1 mole of this one, wrong. Volume occupied by 1 mole of gas, wrong. Mass of 1 mole of substance, wrong. So the answer is A. Oh. Okay, number 3. Metal, why is soft and shiny? It reacts with water to produce a solution which turns the red lemon pepper to blue color. So red lemon pepper to blue means it is alkaline. Okay, so alkaline metals is soft and shiny. So you have to know that. So following, which one is the alkaline metals? So the answer is C lah. Okay, obviously. So potassium, like sodium, lithium, or alkaline metals. So the others all are in the transition metals. Number 4. Which of the following is an ionic compound? A. Again, it is ions. Ionic compounds means formation from the ions. Ionic compound consists of metal with non-metal. So here, water is covalent, sharing of electrons. Sulfur trioxide also covalent, ammonia also covalent. So these 3 are covalent compounds that share the electrons. So only one is a ionic compound. So because it consists of magnesium ions and bromide ions, so it forms an ionic compound. Question 5. Which of the following is correct about an electrolyte? Okay, so we look into the explanation. Which one is the best explanation? It has free moving ions in the aqueous state. Okay, this one is actually correct. Exists as liquid at room temperature. Not all the electrolytes are in the liquid in the room temperature, so wrong. Dissolve in water. Not all electrolyte dissolve in water. Some it can become molten state. It can conduct electricity in the solid state. Solid state cannot. Must be molten or aqueous state. So the answer is A. In solid state, if it can conduct electricity, so this one is not the electrolyte, it's a metal. Number 6. Which of the following particles in ammonia solution shows the alkaline properties? So alkaline properties, okay, so it's a hydroxide. Okay, so hydroxide is responsible for the alkaline properties. Hydrogen is responsible for the acidic properties. So this one is for alkaline. Number 7. Okay, which of the following salt can be prepared by precipitation reaction? So precipitation reaction, another name for it is double decomposition. Okay, and then actually this one, precipitation reaction, is used to prepare the insoluble salt. So insoluble salt, you have to remember. Okay, So number 1, zinc nitrate. Okay, if you see nitrate salt, all are soluble. So 1 is out already. So 1A out, D out. Okay, barium sulfate. Okay, so barium sulfate, yes, it is insoluble. Sulfate, huh? Sulfate, it has lead sulfate insoluble, barium sulfate insoluble, and then calcium sulfate insoluble. Oh, okay, so barium sulfate is insoluble. Then silver chloride, yes. Okay, chloride salt, you have a silver chloride, lead 2 chloride, and then mercury chloride is insoluble. Then number 4, potassium carbonate. Okay, so potassium or sodium potassium ammonium salt are soluble. So this is soluble. So the answer is 2 and 3. So it's B. Oh. Okay, next. Number 8, calcium carbonate with hydrochloric acid produce a calcium chloride carbon dioxide in water. So based on the chemical equation, okay, what changes can be observed to determine the rate of reaction? Huh? So to determine the rate of reaction, so normally I will suggest the student to see whether it has a gas or not. If here got gas, okay, carbon dioxide gas is very easy to collect, so we will see the collection of the gas. Okay, so volume of gas increase, mass of the reactants increase, should be decreased. Okay, then volume of reactant solution decrease, no, not related. And precipitation produced is reduced. There is no precipitation, so is this one. Volume of gas liberated increase, okay, over the time. So from there we can determine the rate of reaction. Question number 9. Which of the which diagrams shows the arrangement of particles in alloy? Alloy. So alloy, it consists of 2 or 3, more than 2 types of atoms, different types of atoms and different size, different type and different size. Okay, so A is out now. We also say all are same size. B also out. C different size, but they are not packed closely. This is more to like the molecule. Okay, see, so this one. D is the arrangement of the alloy. Alloy. Okay, question number 10. The following equations represent the reaction between the propene and chlorine. Propene is a carbon-carbon alkene, so it has carbon-carbon double bond. Okay, so carbon-carbon double bond. Propene, it has 3 carbons. So it's whether it is at let's say I put it here, the double bond. Okay, so remember, whenever the addition reaction occur, so the double bond, it will break to form 2 new single bond. In other words, it will forms 2 new bonds here, this carbon and this carbon, this one no more. So in other words, the chlorine, okay, the chlorine, it needs to go to 2 different carbon atoms here. So let's say 1 carbon go here, another one go here. Okay, it cannot goes to the same carbon atoms. Okay, so for example, okay, this one and this one, so it cannot be the chlorine atoms cannot go into same carbon atoms here, so this one is wrong. Okay, then let's say here B is also wrong, because chlorine, it has only 2 chlorine atoms, so this one wrong. Okay, also wrong. Then C, okay, C is correct. This one is Cl. Okay, this one is correct. D is wrong, because only 1 Cl. So another Cl should go either here or here. So the answer is C. Which of the following occur during oxidation? So oxidation should be gain of oxygen, okay, and not gain of hydrogen, should be loss of hydrogen. Okay, loss of electrons, correct. Okay, decrease in oxidation number, so this one should be increase in oxidation number. So you have to remember this, what happens during the oxidation, and then the reduction is totally reverse. 12. This type of energy is called as, so temperature increase, normally heat is released. So heat is released, so it's exothermic. Number 13. Okay, Camnon wants to bake a cheese tart which is sweet but has low calories, so and attractive in colors. So low calorie is number 1. Number 2 is attractive in colors. So number 2. So there, which substance should be added into this cheese tart? Okay, so here number 1, we have to find the sweetener which is the low calories. So low calories, monosodium glutamate is MSG, is actually is a flavoring. So here not request you the flavoring, so MSG is out. So aspartame, yes, aspartame is sweetener but in the low calories, okay, but the colors, okay, benzoic acid is not the coloring, so tartrazine is the coloring, so it's D. Okay, next, this model consists of discover this model. So this model actually is the James Chadwick. So it consists of nucleus, proton and neutrons, and then it consists of surrounded by the electrons in the electron shells. So James Chadwick. Okay, so this diagram shows the apparatus to determine the empirical formula for copper 2 oxide. The dry hydrogen gas must be flowed through the apparatus for several minutes before the heating of copper 2 oxide. So what is the reason to be taken? So in actual fact, this action is taken to reduce or to expel all the oxygen inside, or the air inside the combustion tube. Okay, so you have to flow through the combustion tubes for a few minutes before you light up here. Okay, why? Because if the mixture of the hydrogen and the oxygen gas, you light up, and then it will cause an explosion actually. Oh, yeah. Okay, so to ensure all the copper change to copper to oxide change to copper, no. To prevent the copper from reacting with air to form the copper 2 oxide, no. This is after the heating of the copper 2 oxide. Okay, after all the copper 2 oxide change to copper, okay, then you stop. Then you have to flow the hydrogen gas for another few minutes to ensure or to prevent the copper from reacting with the air to form the copper 2 oxide again. So we don't want this to happen. Okay, so C, to ensure all the air has been removed so that explosion can be prevented. Yes, because the combination or mixture of the hydrogen and oxygen will cause the explosion if you light up. Then D, to prevent the water from flowing towards the hot porcelain dish and then crack the combustion tube. Oh no, this one not the reason. Okay, 16. Okay, table 1 shows the atom E with its proton number and nucleon number. Okay, So 5 protons and nuclear number is 11. So actually we can get the information. If we just want to know the group and the period, we just need to see the protons, because protons same as electrons. So electrons, so the electron arrangement will be 2, 3. Okay, 2, 3. So it has 2 electron shells occupied with electrons. So it's group 2. Sorry, period 2. Then it is group. So 3 valence electron, it is belongs to group 13, not group 3. So group 13. Okay, so the answer is D. 17. Table 2 shows the electron arrangement for the S and T. So S and T. So S, it has 4 valence electrons. T, it has 7 valence electrons. So both are non-metals. So non-metal with non-metal, it forms a covalent compound because they are sharing the electrons. Covalent. So covalent, covalent. So ionic is wrong. Okay, now what is the formula? Formula of the bond form. Okay, formula of the compound. Okay, here actually we can do a very simple calculation here. Let's say S, it has 4 valence electrons, so it still need to share another 4 electrons. Okay, then T, it has 7 valence electrons. It need to share 1 electrons to achieve octet electron arrangement. So here we can interchange it, 1 and 4. So it becomes ST4. So meaning that the answer will be ST4 is A, the answer. Okay, 18. Okay, diagram shows a simple vortex cell. So X and iron, voltmeter here. So X electrode is a negative terminal. Which metal is suitable to be used as an electrode X? So meaning that you have to choose a negative terminal, which means it must be higher than iron in the electrochemical series. So that's make it to become a negative terminal. So okay, so X can be magnesium. Lead, no, because lead is lower than lead as iron. Copper also no. Silver also no. All are lower. So A is the answer. Okay, 19. Which pair of the acid is classified correctly? Okay, correctly. So monoprotic acid means you produce 1 mole of hydrogen ions. Diprotic acid, you produce 2 moles of hydrogen ions when it ionizes in water. So, okay, monoprotic acid. So sulfuric acid, no, it's a diprotic acid. Tannic acid, okay. Carbonic acid actually is a diprotic acid also. Monoprotic. Hydrochloric acid, yes. Okay, so A is out already, C is out already. So we just check B and D. Okay, B, okay, sulfuric acid, yes, you will produce 2 moles of hydrogen ions. H2SO4, so produce 2 moles of hydrogen and sulfate ions. So yes. Ethanoic acid, no, is a monoprotic acid. Monoprotic acid. Okay, now I show you carbonic acid actually is H2CO3. So you produce 2 hydrogen and carbonate ions. So it's actually is a diprotic acid as well, but it's a weak acid. Hydrochloric acid is correct. Is a monoprotic acid. Ethanoic acid is a monoprotic acid. So when ionized, it produces 1 mole of hydrogen and ethanoate. Okay, so monoprotic acid. So the answer is B. 20. Which of the following ions forms a white precipitate when dissolved in excess ammonia solution. So in the ammonia solution, okay, so it is the zinc. Question 21. What is the properties of ceramic that makes them suitable to be insulating layers in the lining of the furnace? So here, one of the most important properties of the ceramic is it can withstand high temperature. So the answer is related to heat insulator, which make it to becomes layers in the lining of the furnaces. Okay. Number 22. Diagram 4 shows the electron energy profile diagrams for a reaction. So which of the following correct label the activation energy? So activation energy, remember, it must be from the reactants. So this is the reactants. So reactants is here to the peak of the curve here. Okay. So A is wrong because it's not over the peak. So it should be B should be the answer. C is wrong. C is wrong because this is a energy level for the products to the peak of the curve here. So C is wrong. D, actually, if we want to make it more accurate, this one actually, if it is the delta H, okay. So activation energy is from the reactants to the peak of the curve here. So B is the answer. 23. Okay, diagram shows the natural change of the occurs on the latex. Latex is the rubber. Choose the substance which is suitable to be added to latex to speed up the above changes. So this one in the liquid form, this one not very clear, but we know that it is changed to the solid. Solid coagulates already. So after 1 day. So if you want to speed up the above changes, meaning that you want to speed up the coagulation of latex, you have to add in the acid, formic acid, weak acid. Okay, why? Because the rubber molecule actually consists of it's surrounded by the protein membranes, surrounded by the negative charges. Okay, so if it exists as negative charges, so with another protein membrane here also have the negative charges, so when come closer it will repel, okay, because of the same charges. So no collision between the rubber molecules, so it cannot break up and then cannot coagulate. Okay, then the formic acid actually it will release the hydrogen ions. So hydrogen ions, it can neutralize the negative charges here. Okay, so negative charges are gone, so becomes neutral. Once they are neutral, they can collide easily. So once they collide easily, the rubber molecules, the protein membranes will break, and then the rubber particles inside, they will combine together. Okay, then you will coagulate. The following chemical equations shows the reaction between the carbon and the copper 2 oxide. Okay, yeah. So which of the following statement is true about this reaction? So in other words, carbon is able to displace the copper from the copper 2 oxide. So it forms the carbon and the copper metal, carbon dioxide and the metal. Okay, so which one is true? Okay, brown solid is formed. Okay, correct. Because of the copper. And carbon acts as an oxidizing agent. So is it oxidizing agent? Meaning that it undergoes reduction. Is a carbon undergoes reduction? Yes or no? Because you see here carbon actually is gain the oxygen, so actually it undergoes oxidation, so it should be the reducing agent. So 2 is out. Okay, 2 is out, meaning that A is out. 2 D also out. Okay, next. Number 3, the oxidation number for copper increased from 0 to +2. So here actually the oxidation number for the copper here, it should be +2. Okay, this one is a metal already, so should be 0. So it should be +2 decreased to 0. Okay, so this one is wrong. Oh, then okay, decrease from +2. Okay, so it's 1 and 4. So 1 and 4 should be boy. Okay, 25. Okay, hydrochloric acid with potassium hydroxide produce a potassium chloride and water. Heat of neutralization is -57 kJ per mole. Okay, so calculate the heat change. Calculate the heat change is a Q. Okay, so yeah. Okay, first thing we can do is we can calculate. We write out the equation first. Okay, so Q actually is the mc theta. Seems like here we are not given the temperature change. Okay, never mind, we leave it first. Okay, next. Okay, you are given the delta H. Okay, now we can calculate the number of mole. Number of mole for hydrochloric acid and potassium hydroxide, both are the same. So here you can calculate any one of these, or potassium hydroxide. They are the same because so we use mv over 1000. So m concentration is 0.1, v is 50 over 1000. So you will get is 0.005 mole. We can try. Okay, so after that we know that the delta H equals to Q over mole. So delta H is 57. We need to find a Q. Mole is 0.005. So meaning that Q is 57 times 0.005 equals to 200. Sorry, yeah, 200. Yeah, okay, 0.285 kilojoules. So equals to times 1000, so it's 285 joule. Okay. So in actual fact, sometimes you see the question will ask you the temperature change. If here you are asked to calculate the temperature change, you can replace the Q into the Q equals to mc theta. Then you can calculate the theta here. Okay, yeah, also can be asked. So here is just asking you the Q, so it's 285. So any question you can leave at the comment below. Okay, 26. It shows the structure of the X. So X, if you see this one, SO4, so you know this is the detergent. Detergent. So what is X? So is what? Salt, carboxylic acid, sulfuric acid is detergent. So it's detergent. Okay. So if you see the it is carbonate like this, okay, and then the tail like this. Okay, this one it will be salt. Okay, very easy to recognize. 27. Which substance is an element? Element means only one type, one type of atom. So one type of atom, naphthalene, no, it has C and H. So it's a compound already. Steam is a H2O. So no, it's that hydrogen, it has oxygen. A definitely no, it has more than few kind of atoms or gases. So definitely no. Neon, yes. Okay, neon, it has only one type of atoms, neon. Okay, Ne, the formula. So D. Okay, 28. Which of the following pair of compounds are same homologous series? Okay, so homologous series in the SPM level will be alkane, alkene, alcohol, carboxylic acid, and ester. So we check one by one which one is under same homologous series. So C2H4, C3H6 are not very clear. So this one, yes, because it's alkene. Okay, now we look at this C2H6. This is alkane. C3H6, this is alkene. So no. This one is OH, so this is alcohol. Okay, this one actually COOH should be carboxylic acid. Okay, this one is alcohol. This one is carboxylic acid. Okay, so DA is the answer. 29. Metal Y react with chlorine to form a green solid YCl2 and brown solid YCl3. Okay, in other words, okay, so you see here YCl2 and then YCl3, meaning that this Y, it has 2 positive, then Cl minus. This one is actually Y3 positive, Cl minus. Okay, so here it has 2 different oxidation number. So different oxidation number is a special characteristics of transition metals. So alkali no, halogen no, noble gases no. So it's a transition elements group. Okay, 30. Table shows the chemical formula for 2 compounds. Two compounds. So what is the property of both compounds is similar? So actually, let's see here. This one actually is the ester. This one is CH3Cl3 is this is under like alkane now, alkane group. Okay, but alkane is only consists of carbon and hydrogen only. This one already mixed in the chloride, chloride. So they are considered carbon compound. Okay, so which property are similar? So melting point no, because they have different structural formula, so there will be different melting point. Solubility, yes, it is. They are soluble in organic solvent but insoluble in water. Density, no, because they have different molecular size. Okay, then molar mass, definitely no. So B, solubility will be the similarity. So they are soluble in organic solvent. Diagram 7 shows the apparatus for experiment involving a chemical cell. So we look at here: copper metal, zinc metal, porous pot, zinc sulfate solution, copper 2 sulfate solution. Okay, so which of the following statements are true about the above experiments? Okay, so let's look into this reaction here. So zinc metal and copper metal here. So zinc as a negative terminal, as a anode. Okay, anode. Okay, so it's negative. Copper is a cathode. as a positive. Okay, so zinc at the anode, you undergoes oxidation. So here we can directly write out zinc undergoes oxidation, forms the zinc ion, so release 2 electrons. Okay, so meaning that zinc you becomes thinner at the end. Okay, at the cathode here, it has copper 2 sulfate solution. So inside the copper 2 sulfate solution, we focus to positive ions. So it has copper 2 ions and hydrogen ions. So the lower position ions will be selectively discharged. So copper 2 ions will be selectively discharged. So copper 2 ions, you gain 2 electrons, it forms the copper metal. So you will see brown solid is formed here, becomes thicker. Yeah. So cathode undergoes reduction. Okay. So copper metal becomes thinner. No, it should be zinc. Yes, zinc. Zinc metal becomes thinner. Yes. Okay. Blue solution is fading. Fading means becomes like light blue. At the end, it will become colorless. Okay, this one correct because the copper 2 ions is blue color. So you gain the electrons, it forms a copper metal. So meaning that the concentration of the copper 2 ions is decreased. Okay, so is decreased means it will fix because the copper 2 ions decrease. So this one is correct. Copper 2 ions decrease. So brown solid is formed at the zinc electrons. No. Okay, it should be at the copper electrons. So it's 2 and 3. 2 and 3 is C. Okay, C is the answer. Okay, next. Okay, diagram 8 shows the arrangement of particles in the state of matter, in 3 sets of matter in the room temperature. Okay, this one is at the solid state. Okay, but this arrangement actually is wrong. It's 2 times 5. Okay, so for the solid state, it should be at least 3. 3 times 3. At least 3 times 3. Okay, so here you have to pay attention here. If 2 layers is not enough, must be 3 times 3. So meaning that another layer should be drawn here to show it is a solid state. This one is a liquid state, this one is a gas state. So we see X bromine is not the solid state, it should be in the liquid state. So A is out already. Okay, naphthalene, yes, it is a solid state. Okay, then bromine in the Y is a liquid. Okay, this one correct. Nitrogen, yes, is a gas. Okay, next check. X is nitrogen, nitrogen is gas. No, wrong. So C out. Naphthalene, this one nitrogen is a gas, but here Y it should be in the liquid. So this one wrong. These two reverse. So the answer is B. 32 is B. Okay, 33. Solution Y, it forms when it add into the sodium hydroxide, it forms a green precipitate. Green precipitate. And then if add in dilute hydrochloric acid followed by barium chloride, okay, it will form a white precipitate. Okay, so if you see this one, barium chloride, we know it is a test for the sulfate ions. So it shows white precipitate means it contains the sulfate. Confirm. Then if with the sodium hydroxide, it forms a green precipitate, so it's iron 2. It's iron 2. So the answer should be iron 2 sulfate. Okay, iron 2 sulfate. It's not the lead, not the lead. It should be iron 2 sulfate. Not chloride, because chloride, if we want to test the chloride, we are not using the barium chloride, we are using the silver nitrate. Okay. 34. Okay, diagram 10 shows the effect of a weight that dropped on the steel ball bearing placed on the bronze and the copper block. Okay, the bronze is alloy. Copper is a pure metal. So from here we know that the alloy is harder compared to pure metal. So what is the characteristic shown by the bronze block? So bronze, when it's knocked, the dent actually it shouldn't be so big. It should be the maximum. It should be the dent formed by this steel ball bearing only lah. Okay, but here at least we can see this one is the diameter of the dent is smaller. Okay, compared to this one. So with see lah, strong and harder. Alloy is harder, bronze block. Okay, next 35. 0.2 moles of magnesium tag react with excess dilute nitric acid after 30 seconds. 0.05 mole of magnesium remains as residual. What is the average rate of reaction? So average rate of reaction here we have, okay, let's see, the time taken is 30 seconds, meaning that divide by 30 seconds. Okay, now we want to see the unit is mole, so meaning that the uphill should be mole. So it used 0.2 mole of magnesium. So initially is 0.2. So remains as residue means 0.05 remains. So meaning that the mole for the magnesium tag that react would be 0.2 minus 0.05. Okay, mole. So we can use your calculator. So you will get 0.005 mole per second. 5.0, sorry, my mistake. Okay, 36. It shows a structure which represent organic compound of P and Q. So P, we see this one, this is alcohol. Okay, we see this one, this is carboxylic acid. Okay, so what is the name of the compound form if P react with Q? Okay, with using the concentrated sulfuric acid as a catalyst. Okay, so you have to know if alcohol react with carboxylic acid with the catalyst of concentrated sulfuric acid is esterification. Okay, esterification. So here we know that what is the name for the ester form. So we have to take out the name for the alcohol and the carboxylic acid. So 2 carbon alcohol is actually ethanol. Okay, so ethanol, it becomes alkyl later on, so it becomes ethyl. So this one is carboxylic acid. So carboxylic acid with 3 carbons, so actually is a propanoic acid. So propanoic acid in the ester, it becomes propanoate. So we combine the name will be ethyl propanoate. Ethyl propanoate. So D is the answer. Okay. Next, magnesium react with hydrochloric acid. State the process happens to magnesium and hydrogen ions. Okay. So we can write out the equation. So magnesium react with hydrochloric acid. So it forms a magnesium chloride and hydrogen gas. So the magnesium change to magnesium chloride, so 0 change to positive 2. So increase in oxidation number, so it's oxidation. So hydrochloric acid, this one is +1, change to 0 because molecule 0, hydrogen molecule. So this one is reduction. So here, magnesium is oxidation, hydrogen ions is reduction. So A lah, A is the answer. Okay. C and D definitely out because it cannot be both oxidation or reduction. Okay, a student wants to study the heat of displacement by using the lead metal. Which of the solutions are suitable to be used in this experiment? So lead, meaning that you have to choose the metal in the solution which is lower than lead in the electrochemical series, or less electropositive than lead. So zinc is more electropositive than lead, so zinc is out. So 1 is out, A out, B out. Okay, copper 2 nitrate, yes, copper is lower than lead in the electrochemical series. Silver also can. Magnesium, no, magnesium is more electropositive, so it's 2 and 3. 2 and 3 will be C lah. Okay, next. Okay, diagram 12 shows the child having fever. So it is a children. So her mother, his mother should be his mother, right? It's a boy, right? His mother take him to a doctor. What medicine the doctor prescribed to the children here? Okay, to this boy. Okay, A is a paracetamol, yes, but it is very acidic, so cannot be given to children or pregnant women. Okay, because it's very acidic, it will cause the internal bleeding, so be careful. Barbiturate actually is a psychotherapeutic. It's a sleeping pill. So penicillin is an antibiotic. This one is for sleeping pill. Psychotherapeutic medicine. So penicillin is an antibiotic. So paracetamol, yes, this is neutral, and it can reduce the fever. Okay, and then it is suitable for children and pregnant women. Okay, 40. Every morning, Muthu helped his father to collect latex from the rubber tree. He found that the latex coagulates after a few hours. How Muthu can prevent the latex from coagulating? Okay, just now a question is mentioned about how to speed up the coagulation of latex, right? So just now we said you must add in the acid, because acid, it contains the hydrogen ions. It can neutralize the negative charges on the protein membrane here. Okay, draw again. Negative charges. Okay. So if you want the rubber to coagulate, you need to add in the acid, because the hydrogen ions, it can neutralize the negative charges. Okay, then they can collide, then it will break, and then it can combine together, coagulate. But if you don't want it to coagulate, meaning that you need to maintain the negative charges here. So negative charges, actually it will be neutralized by the acid produced by the bacteria. Okay, so meaning that if you put it overnight, the latex still will coagulate. Okay, so in order to prevent the latex from coagulation, you have to solve this problem. Okay, how to get rid of the hydrogen ions produced by the bacteria? We have to add in the alkaline to neutralize the positive charges from the bacteria. Okay, so definitely ethanoic acid cannot. Okay, we have to add in a weak alkaline such as ammonia. So ammonia, you produce actually produce hydroxide ions. It will neutralize the hydrogen ions produced by the bacteria. Okay. So once it's neutralized, so the negative charges at the protein membrane of the rubber molecules here, it will remain negative charges. So it will repel, always repel with each other. So no coagulation can occur. Next, 1.2 gram of element X react with 8 grams of element Y to form a compound with the formula of XY2. So what is the relative atomic mass of the X? Okay. So here actually we can we work from the backward. Okay, let's say now we have X and Y. Okay, X, the mass is 1.2 gram, Y is 8 grams. Okay, so normally if we divide by the molar mass, so 1.2 divided by the X, we need to find out. Y is 80 grams, so you will get 0.1 mole. Okay, then you'll be given X and Y2, so meaning that the ratio will be 1 and 2. So from here actually we can use a cross multiply to get the value of the X. So we can work it out. 1.2 over the X times 2 equals to 1 times 0.1. So meaning that it's 2.4 over X equals to 0.1. So we need to find the X. It's 2.4 over 0.1. Actually it's 24. So it's 24, the answer. 42, table shows the number of neutrons and nuclear number of atom X and Y. Neutrons, nuclear number. So from here we can get the value of the protons. So 24 minus 12, so protons. Proton actually same as electrons. So is 24 minus 12 is 12. This one 16 minus 8 is 8. Okay, 8 proton or electrons. So if we have the electrons, so we can write the electron arrangement. This one is 282. This one is 26. So 282 is a metal. 26 is a non-metal. So this one actually is a magnesium. This one is a oxygen. So metal, non-metal, it will form a ionic compound. So properties of the compound, so ionic. So ionic compounds property can conduct electricity in all state. No, it can conduct electricity in the molten or aqueous state only, because it has freely moving ions. Soluble in water, correct. React with alkali, no. Produce more sweetness when burned in air, no. So soluble in water. So another one is melting and boiling point will be high melting and boiling point. Okay. 43. Okay, diagram shows the electron arrangement of the compound produced. Okay, Q produced when atom P react with the atom R. Okay. So where is the group and the period? Group and the period. Okay. Now here we can see it is 2 positive initially, meaning that the electron arrangement is 2, 8, 2. Then lost 2 electrons to the R, then it forms a octet electron arrangement to 8. This one, it should be 2 negative, so it should be 2, 6. Then it gained 2 electrons from the, received 2 electrons from the P. Then it achieved octet electron arrangement, so it forms a 2 minus, 2 negative. So we can see P is a group 2, correct? Period, it should be period 3, so not period 2. Group 2, correct? Okay, so group 18, wrong, wrong. Group 2, period 3, this one correct. Group 16, no, wrong. Okay, this one I think the answer is C. Group 16, 6 valence electrons, or 16, period 2. Okay, so C is the answer. Okay. Now zinc and iron, again, I think this is a vortex cell. So zinc more electropositive, this one less electropositive. So this one becomes the anode, negative terminal. This one cathode, positive terminal. So what modification can be done to make the bulb shine more brightly? Most brightly. Most brightly means we need to choose the distance between the two metals, which is the furthest. Okay. Let me see. Substitute the dilute sulfuric acid with a copper 2 sulfate solution. It won't help a lot. Use the thick and wider metal plate. No. Substitute the iron with aluminium. Substitute iron with copper. Okay, I think this one will be best because we most brightly, meaning that the distance between the iron and zinc and the iron is closer compared to zinc and copper. Okay, zinc and the copper is further compared to iron. Iron is somewhere here. So if closer, meaning that the potential difference is lower. So the bulb, it won't shine that bright. Okay. 45. Okay. Following shows sulfuric acid. Okay. What is the volume of? Okay. Can neutralize. Okay. For this neutralization, I always ask my students to use this formula. Okay. MAVA over MBVB equals to A over B. Okay, so here A, you just remember A refers to acid, B refers to base, base. So we replace in all the information. Okay, MA, molarity for the acid is 0.5. Volume of acid is 50. MB is 0.5. Okay, volume of potassium hydroxide. So VB is the one you need to find. Then here A is the number of mole for the acid. So number of mole here is 1. So we use 1. B is the base for the alkali, for the is 2. So we use cross multiply again. So is 0.5 VB equals to 0.5 times 50 times 2. So VB equals to, use your calculator, you will get VB is 100 cubic centimeter. So you see. Okay. 46. Which of the following pairs of substance is most suitable to prepare copper 2 sulfate solution? Okay, copper 2 sulfate solution. So remember, copper 2 sulfate solution. So hydrogen is here, copper is here in the electrochemical series. So copper is lower than hydrogen ions in the electrochemical series. So we cannot use this copper metal to displace the acid. So C is out. So remember. Okay, so sulfuric acid with copper 2 carbonate, acid with metal carbonate, yes. So copper 2 sulfate is a soluble salt. So soluble salt, not sodium, potassium, ammonium. Normally we can use 3 methods. Metal oxide with acid, metal carbonate with acid. Another one is reactive metal with the acid. Okay, so the acid here must contain the sulfate, means must use the sulfuric acid, sulfuric acid, because it will produce the sulfate ions. Then here, metal oxide, metal carbonate, and reactive metal. Just now I mentioned to you already. So copper is not the reactive metal, so you cannot use the copper. So this option is out. No? Then you have only two options here: metal oxide with and metal carbonate with the acid. So here, copper 2 carbonate, yes. Metal carbonate, yes. Because if here copper 2 oxide, we must react with the acid. So acid, you cannot use the ammonium sulfate. So no, you must use the acid. Okay, so this one also cannot. So the answer is A. Okay. 47. Okay, even in excess, heat represented, okay, cause the temperature of 500 cubic centimeter of water to rise from 28 to 53.5. What is the heat of combustion? So meaning that you need to find the heat of combustion. Okay, so here we can, okay, first we can calculate the Q equals to mc theta first. So m is the volume of water, so it's 500. C is 4.2. Theta is the temperature change. So from 53 minus 28, so we can find the theta. So you will get roughly is 53550 joule. So we can round change to kilojoule. So means that 53.55 kilojoule. Okay, so this is for Q. Number 2, we need to find the mole. Mole, we can use the mass of the alcohol divided by the molar mass. So the mass is 1.48 gram. Molar mass for the butanol, so we have to put in all the AR. C is 12, H is 1, O is 16, then H is 1. So we total out, use your calculator, it will be 74. 74. So it's given here. So 74, you will get the mole is 0.02 mole. Okay, so finally we can find the delta H, heat of combustion. Delta H is the Q over the mole. So 53.55 divided by 0.02. So you will get 2677.5 kilojoule per mole. So in your calculation, you don't have any negative sign. So at the end, you put in a negative sign to show it is an exothermic reaction. Exothermic reaction. So it's boil. Okay, 48. Okay, table shows the volume of hydrogen gas collected when zinc powder react with excess hydrochloric acid. Okay, what is the average rate of reaction? So average rate of reaction, so again, divided by the time. Time for the reaction to be completed. So meaning that if you see here, time is the minute. Minute 1, 2, 3, 4, 5. So volume of gas collected 0, 30, 32, 32.5, 33, 33. So here at minute number 4, it turns to 33. Minute number 5 is also still remains the same. In other words, actually in minute number 4, the reaction already completed. Okay, so the time will be 4th minute here, not 5th minute. So meaning that the volume is 33 divided by the time is 4th minute. 4th minute we have to change to 240. Sorry. Okay, so it's around 0.14 cubic centimeter per second. So 0.14. Okay, yeah, 48. Okay, 49. Okay, the decomposition of lead to nitrate, it forms a lead to oxide, oxygen, and a brown gas. So which of the following is a balanced equation? So decomposition, it forms the lead oxide, oxygen, and brown gas. Brown gas actually is a nitrogen dioxide, or nitrogen dioxide, and oxygen. So we have to balance the equation. Okay, next we see this one, oxygen 2 times 6, so A definitely out already lah. Okay, let's see B. Okay, decomposition never use the plus oxygen, decomposition. Okay, so decomposition is a heat, you heat it and then it decomposes. So the answer is C lah. So is, and then if you can check, and then it is balanced. Okay, if you are still cannot, you can leave at the comment below. Then I will try to explain more on it. Okay, last question. Diagram shows the apparatus used to investigate the reaction of iron 3 nitrate solution with potassium iodide. Okay. Iron 3. Okay. So what is the correct observation for both? So here, okay, so more electropositive metal we do not look at, we look at the iodide now. So iodide, what happened? So iodide definitely will change to iodine. Okay, so oxidation, lost electrons, so 2. So this one undergoes oxidation. Okay, so iron 3. Okay, iron 3, it will change to iron 2. Okay, iron 3 to iron 2, so reduction gain electrons, 1 electron, so undergoes reduction. So this one is anode, like if you want to put in the terminal, this one is cathode. So meaning that this one is negative, this one is positive. Okay, so what happens? Okay, what is the observation? Okay, here iodide will be colorless, iodine is brown color, colorless brown, this one correct. Okay, iron 3 is brown color, iron 2 is green color, so this one correct. This one this one green to brown, no, this one wrong. Purple to colorless, also wrong. Colorless to brown, this one correct. Green to brown, okay, this one wrong, reverse. This one should be reverse. Green to brown, okay, no. Orange to green, no. Okay, so the answer is A. Okay, so I hope that my explanation is not too fast for you, but if you have any questions, you still can ask at the comment below. Okay, I hope this video helped you. Okay, thank you very much.